solving differential equations. So we're going to look at, for this one, solving differential equations that have the form dy dx equals f of x times g of y. So when we solve these, we are going to get the dependent variables on one side and the independent variables on the other side. So the dependent variables being the y's and the independent variables being the x's. And then because we're going to have dy or y in terms of dy and x's in terms of dx, we are going to integrate both sides. So once you do the integral of both sides, you're going to add a constant. We'll do it to the side with the independent variable being the x, and this will give us the general solution. Now we'll solve for c if required, and we'll always rewrite with the dependent variable as the subject, so we'll get y in terms of x, unless asked otherwise. Here's an example from a HSC. So consider the relationship. Consider the differential equation dy dx equals x over y, and which of the following best represents that. So multiplying both sides by y and dx, you get y to y equals x dx. Copy both sides and you get y squared over 2 equals x squared over 2 plus the constant. Multiply by the 2, get your y squared equals x squared. You would get 2c, but remember a constant is just a value at the end, so it's just a constant can stay there, and that answer is A. From the 2020, solve dy dx equals e to the 2i, finding x as a function of y. So a bit different, we're going to get x in terms of y. So getting the independents and dependents on the same side, so dividing by e to the 2i gets you e to the minus 2i to y, and just dx, and then we're going to integrate. So the integral of e to the minus 2i is minus a half e to the minus 2i, and the integral of dx is x, and then you've got your plus c, so we get x equals minus a half e to the minus 2i plus c. Now, once again, does it matter if it's plus c or minus c? Not really, because it's just you've got a constant that you're trying to find. Here's one where we're going to find the particular solution, because we've got to pass it through a point. So the last two were general solutions. This is the particular solution that passes through the point 0, 1. So, same thing, get the dependent variables on one side and the independent variables on the other. So you get 1 over y to y. That's a nice one that we can integrate. X over x minus 2, that's going to take a little bit of work to do that, dx. So this comes from the 2022 HSC. So we're going to integrate both sides. But to integrate the right-hand side, we're going to manipulate that. So we're going to get, we've got a denominator of x minus 2. So let's work on the numerator getting x minus 2. And you can't just make it subtract the 2, you need to add the 2. That'll split it into 2 separate fractions, which will allow us to get the integral of 1 plus 2 over x minus 2. So now integrating both sides, you get ln y, 1 integrates to x, and 2 over x minus 2 integrates to 2 ln x minus 2 plus the constant. Substituting in the value 0, 1, you get a constant of minus 2 ln 2. So we get ln y equals x plus 2 ln x minus 2 minus 2 ln 2. Now this doesn't ask you to get y in terms of, but let's have a look at how that would operate anyway. So that would get us y equals e to the, okay, so we do get the y by itself. But alternatively, we could get the solution by making the x as ln e to the x. That would allow us to get all the logs, and obviously if we've got log of one side equals the log of the other, we can just remove the logs. So that gets us y equals e to the x minus 2 or squared over 4. Thank you.